Hi everyone, my name is Yelyzaveta Dzenis and I'm a bachelor student of Kharkov National University of Radioelectronics, Department of Media System and Technologies. And today I will present procedural modeling and explain its role in creation of 3D objects. In this presentation, I will describe the key principles of this approach, outline the main techniques, and explain why it's widely used in the contemporary digital production. Before moving to the specific methods, it is important to understand the main idea of the procedural modeling. This approach focuses on the definite rules and algorithms that describe how objects are created rather than modeling them manually. The relevance of procedural modeling is linked to the rapid growth of industries such as game development, film production, and simulation technologies. These fields require large-scale environments that contain a high level of detail and variation. Manual modeling cannot efficiently handle such demands, as it requires a significant time and constant human involvement. Procedural modeling improves this process by enabling automated generation of complex scenes, while also allowing quick adjustment through the parameters changes. The main object of this research is to analyze different procedural modeling methods and evaluate their effectiveness in generating 3D objects. This involves understanding how various techniques operate and how they contribute to the modeling process. Another important aim is to identify the strengths of procedural modeling, including the efficiency, scalability, and flexibility. The research also considers how these methods are applied in the real-world scenarios and modern production workflows. Traditional 3D modeling is based on the manual creation, where each object is designed individually. This approach becomes problematic when dealing with the complex scenes such as urban environment and natural landscapes. In addition, any modification requires manual editing of the multiple elements, which increases the workload and reduces efficiency. As a result, the process becomes time-consuming and difficult to manage at a large scale. Procedural modeling is a technique in which geometry is generated automatically using algorithms, rules, and parameters. Instead of focusing on the final object, designers define the logic behind the creation. This approach allows greater flexibility as changes can be introduced by adjusting parameters rather than rebuilding the whole model. It also supports the creation of multiple variations without additional work. The central idea of the procedural modeling is the generation of the complex structures from the simple elements. This is achieved through the repeated application of the transformation rules that gradually increase the level of the detail. Such a process reflects principles observed in the nature, where simple rules can lead to the highly complex results. This makes procedural modeling both efficient and powerful when dealing with the incrude forms. L-systems represent one of the earliest procedural techniques. They are based on the recursive rewriting of symbolic sequences where rules are applied step by step to generate more complex patterns. After several iterations, these patterns are interpreted geometrically, resulting in the visual structures. This method is particularly effective for the modeling plans and fractal forms as it reflects natural growth processes. Shape-grammars provide another rule-based approach to procedural modeling. This method objects are divided into small components and transformation rules are applied to each part. This technique is especially useful in architectural design, where it allows the generation of the building with the multiple variations. Starting from the simple base form, it's possible to create a detailed and structured models. Model procedural modeling combines node-based system with the scripting techniques. Node system allows designer to visually organize operation while scripting provides additional control of the complex processes. For example, tools geometry nodes in the Blender 3D make it possible to construct flexible modeling system. At the same time, programming languages such as Python can be used to automate repetitive tasks and extend functionality. Procedural modeling offers several significant advantages. It reduces manual effort by automated repetitive operation and improves efficiency in large projects. Another important benefit is scalability, which allows creation of extensive environments with minimal additional work. Furthermore, parameter-based control enables the generation of the multiple variations, increasing diversity in the final result. Procedural modeling is widely applied in the various fields, including video games, film production, architecture, and simulation systems. In this area, it supports the creation of detailed and large-scale environments. By reducing production time and simplifying complex processes, this approach allows developers and designers to focus more on the creative and conceptual aspect of their work. In conclusion, procedural modeling represents a shift from manual design to the rule-based generation of 3D objects. This approach makes it possible to produce complex and scalable content in a more efficient way. As digital technologies continue to evolve, procedural modeling is expected to play an even greater role in computer graphics. Its integration with the automation and intelligent system highlights its importance for the future development. That's all. Thank you all for your attention.